For this video, I want to talk about how to find the mass of a block if all you know is the force of tension in a string, if this block is on a ramp that is frictionless. So step one is always to draw a picture, which we've done. Step two, draw a free body diagram. So I'm going to draw mine over here so it's nice and big. The force of gravity goes straight down, and the normal force is going to go at an angle, perpendicular to the ramp. I'm just going to F sub n, normal force, and I get the force of tension that goes up the ramp this way. Okay, so there's a couple of things that we need to make sure we know before we move forward. This is a frictionless ramp, so we don't have to worry about friction. And the other thing that I didn't say in this is, let's say that the block is at rest, because that's important. When the block is at rest, then we can say the sum of the forces is equal to 0, or the net force is equal to 0. That means the sum of the forces in the parallel to the ramp direction will equal 0, and the sum of the forces in the perpendicular to the ramp direction will be equal to 0. All right, so first things first, we've drawn our free body diagram. Now we need to sum our forces. So I'm going to sketch in the axes. So this is our parallel to the ramp axis, and this is our perpendicular to the ramp axis. I need to draw in the components of my force of gravity. And so I can look here and I can see I'm going to start at the tip of this arrow and I'm going to draw a parallel to the ramp straight back. This is going to be the force of gravity that's parallel to the ramp. And then the other force of gravity, the other component, is going to be this force of gravity perpendicular to the ramp. Okay. The angle that's inside of here, that's angle theta, which is the angle of the ramp here. So you can think if the ramp got less steep, if the ramp became less steep, this angle would decrease. So that's another way to think about it. All right, so we've done that, and now we need to, what is the mass of the block at rest? Okay, so we know that the force of gravity is the mass times the gravitational field strength. So this is what we're looking for. So we need to find something that has to do with the force of gravity. Whenever you get lost or confused, the first step is to sum the forces. I'm going to sum the forces in the parallel to the ramp direction because I know the force of tension, which is 15 newtons. Because I know the force of tension, I can say that the force of gravity parallel is the force of tension, and the force of gravity parallel to the ramp. We need to put it in a direction here. I'm going to call down the ramp positive. I like the direction of acceleration to be the positive direction. So that means that this is going to be positive. The force of gravity parallel will be positive, and the force of tension will be negative. As I said before, the sum of the forces is 0. So the sum of the forces parallel will be 0 newtons, and that gives me negative the force of tension plus this force of gravity parallel. So we need to figure out what this side of the triangle is. And when I look at this, this looks like the opposite side to this angle. Remember, this is our right angle here. So using SOHCAHTOA, opposite over hypotenuse is the sine. So if I write the sine of theta is the opposite, the force of gravity, parallel to the ramp, that's the opposite side, over the force of gravity. I should have written my force of gravity over here so it doesn't get confused with the force of gravity parallel. All right, and so we can just move the force of gravity, multiply both sides. So mg, or the force of gravity, which is mg, sine theta, is the force of gravity parallel to the ramp. So we can just plug that in right here. mg sine theta. Move the force of tension to the other side. Ft is mg sine theta. Now we're getting to the point where we can start maybe plugging in numbers. I'm going to wait just a minute because I'm going to get mass by itself. So the mass is going to be the force of tension divided by the gravitational field strength times the sine of theta. So force of tension, 15 newtons, divided by 10 meters per second squared times the sine of, let's say this ramp angle is 20 degrees, times the sine of 20 is going to be the mass. And if I did all of my math right, I think that's going to give me a mass of about 4.4. And the unit on that, remember, a Newton is a kilogram times a meter per second squared. So this meters per second squared in the numerator will cancel with the meters per second squared in the denominator, and you're left with 4.4 kilograms as the mass.